This is the problem solving session of lecture 14 on Cosets. About 5 or 6 questions. Here's the first one. Within the context of the dihedral group of 4 sides, so in other words we're talking about the symmetry operations of a square, okay? And here's the group, order 8 members, and you're given 2 subsets, these two, well they're subgroups actually, okay? And you're asked to find the left cosets of this subgroup and the right cosets, and I've started the process of finding the left cosets of this subgroup, and you're asked to do the same for this subgroup as well, the left and right cosets. And then at the end of the question, write down one important difference between the 2 cases. So this being one case, the left and right cosets of this one, and the left and right cosets of this one, and there'll be a difference. Alright, so now look, I haven't bothered to write down the table. I did it once before, and it took a while, and that's not surprising because the order of this group is 8, right? So the group table will be 8 squared. So you'll have, a huge area. I've done it once before, so go back to earlier lectures, or if you have the text, have a look at figure 13.3. So in the previous chapter, in chapter 13, figure 13.3, you'll have the table, and you'll need that table to calculate these left and right cosets. Right, so let's do a few. So here's your subgroup E of A. So we're firstly finding the left cosets of this subgroup. Right? So you just systematically you write down every member of your group, and you left multiply that each member. So you use that member to multiply your subgroup. Right? So this will just be EA squared, and this will then be A cubed, and then this will be A squared, A to the 4th. But that's E, right? Because A to the n, in this case n is 4, so A to the 4 would be E. So you have an E here. A cubed, and then A to the 5th, that's just A, right? Because A to the 4th is 1. And then here you'll just get B, BA squared, and then BA, and then BA cubed, BA squared, B, right? Because you get BA squared, A squared, so BA to the 4th, A to the 4th is E, so just B, so you get B here, and so on, right? Now, so you look at the different ones, the different left cosets that you get, and this is the list that you get, right? When you actually go through all the details. I'm just giving you a kind of sketch, help you along. All right. Now do the same thing for the right cosets. And so instead of having these elements here on the left of your subgroup, they're now on the right. So you get EA squared, and here then you get A cubed. Well, the A's okay. Things start getting interesting when you've got the B. So now this element B is now on the right hand side. Okay, so you'll get B A squared B. Now that is not in the form of B A to some power. So you're going to need the group table to calculate what A squared B is, and you'll find it in the form of B times A to some power, whatever. Right? And similar story for the rest of these. Now, okay, so you find all the different right cosets, and you get this list here. And this list of right cosets is equal to, it's just the same as the list of the left cosets. Right? Well, that's a remark. All right. So we've done half the problem now. Now the other subgroup is BB, It's a group. So you just do the same thing. So instead of having EA squared, you'll have a B here. So you're doing it for this one. So you just do the same thing, and you get a list of your different left cosets for this subgroup, and you'll have another list similar to this. You have another list, a third list, and then you do it for the right cosets. So you'll have these elements here now on the right, and you'll again, you'll get your cosets, find the different ones, and make a list of them. And this time, for this subgroup, for this subgroup, the list of left cosets and the list of the right cosets are not the same. And that's the important difference. Write down at the end of question 1. Write down one important difference between the two cases. Well, that is, in the first case, for this subgroup, the left and right cosets, that list is the same. Right? And for the second subgroup, this one, its left cosets and its right cosets, that list, not the same, different. Now, I could sort of throw in a remark there. If your group is abelian, then your left and right coset will be equal. I'll just throw that out. I'll ask you to prove that as homework. So if your group is abelian, then its left and right coset for the same element is equal. Right? You're asked to find the left cosets of the following. So this is question 2. So you have Z2 and tensor product of the set 0. Now that's a subset, and the group is just Z2 times Z2. 3, sorry. Z2 is in 3. Okay, and you're asked to find the what is it? The left cosets. Now see, here's the subgroup, and so the binary operation is plus. Right, it's plus. Now it's a direct product or Cartesian product if you're thinking about sets, and this is a subgroup of this. Okay, now the general form of this, this will be of this form, right? So what are the elements of this group? Now it's a Cartesian product, remember? So you have these sort of ordered pairs. If you're a bit rusty on how to take the direct product of two groups, or the Cartesian product of two sets, go back a few lectures. So here are the members of this set. Okay, and you're asked to find the left cosets. So you're going to have to binary operate on this by each one of these members of your group, right? Because you're asked to find all. Write out the cosets, the left cosets of this. Now, let's see. So what is this group? Well, its members will be what? Well, naught and naught. It's a Cartesian product, so whatever's here goes here, and there's only one of them. this has two possibilities, 0 and 1 on the left part of your ordered pair, and that's given, that's fixed. Okay, so that's what you've got, and you then to find the left cosets, you just do this kind of thing. Instead of, well, here's your set now of these two elements, and then we binary operate with this one and this one and this one and so on. So so it'll be try a new pen. So it'll be okay plus, that's because the binary operation, and then 0, 1 plus, you do the same thing, and then 0, 2. Yeah, you just systematically go through all members of your group. Right, so then 2, and then 1, 1, 0, and 1, 1, and 1, 2. Alright, so you will end up getting, now it's binary operation plus, and it's modulo 2. Okay? And for this case here, because it'll be modulo 3. So this will just give you the same. You're adding 0 to anything, you just get the anything. So this will just leave you with there's my new box. So this will become just a repeat of this. Right?